All right, so in this section, we are taking notes on solving linear inequalities. So before we start, I just wanted to remind us of what some of these symbols mean. So this one right here, kind of shaped like a bent L, is less than. L is for less than. And then the opposite way is greater than. If it's got the little line underneath, that means less than or equal to. And opposite way is greater than or equal to. So first we're going to talk about the graph of a linear inequality. So that is the set of all points on a number line that represent all solutions of the inequality. So a couple of things we need to go over before we start graphing. If you have a greater than or less than sign, we graph that with an open circle. And by open circle, we mean it's a circle like that. You don't fill it in. For greater than or equal to or less than or equal to, so if it's got that equal to symbol underneath, it's what we call a closed circle. So it is filled in like a dot. That's not a great looking circle, but I think you get what I'm saying. So it's filled in rather than open. So let's graph some of these inequalities here. So if we're talking about all real numbers less than 5, the way we would express that algebraically is like this. X is less than 5, again, meaning x can be anything less than 5. The way we graph that, we've got to sort of make a number line here. So I'm going to start at 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. All right, and then we have to have an open circle because this is just less than, so an open circle on 5. And we draw an arrow going that way to indicate that it's all numbers less than 5. All right. So next one, all real numbers greater than -3. Okay, so let's put 0 over here. And then 1, 2, 3. Here's -3. All right, and then again, it's an open circle because it's greater than, not equal to. And then we draw an arrow going this way because it's greater than. So the trick here is if the x or the variable is on the left-hand side, which I'm gonna, once we get into solving, I'm gonna encourage you to do that. The way you graph your arrow is it's pointing the same way as the inequality. So this is pointing to the left, so we draw the arrow to the left. This is pointing to the right, we draw the arrow to the right. That's just a little trick to remember. All right, so for this next one, I'm just gonna put the 0 here. All real numbers less than or equal to 0. So since it's less than or equal to, we do a closed circle like that. And since it's less than, we're pointing this way. Again, this graph is indicating that x could be anything along this arrow. So anything less than or equal to 0. And the closed circle means it could be 0 as well. Whereas the open circle means it cannot be whatever that number is. So all real numbers greater than or equal to -2. So let's put the 0 here. -1, -2. There we go. All right, so it's greater than or equal to -2. So that means we do a closed circle indicating that it could be -2. It could be equal to -2. And since it's greater than, we do the arrow that way. All right, solving linear inequalities. This should be inequalities. Is like solving linear equations. Your goal is to isolate the variable on one side using transformations, also known as inverse operations, that produce equivalent inequalities. So example 1, we have x minus 4 is less than or equal to 7. We want to isolate the x, so what we're going to do is add 4 to both sides. So plus 4, and what we get is x is less than or equal to 7 plus 4, which is 11. The next one, we have x plus 5 is greater than 9. To isolate the x, we're going to subtract 5 from both sides. So then we're left with x is greater than 9 minus 5, which is 4.